Hey, folks, welcome back to another session by Azure Developer Community, and welcome to the day three of our AI 900 bootcamp, where we are having our mentor, Mr. Santosh Kumar, who is a data engineer at Conziant, a Microsoft certified trainer, and also 6x Microsoft certified, and he's also the Azure Developer lead. So you all must be enjoying the boot camp as you have learned from him from last 2 days. Let's take this boot camp to its finishing stage, and we hope that it's going to be really very helpful for you to crack AZ 900 exam, whether you are planning it right now or somewhere about in future. So you won't have to spend too much money on the resources like sir has explained each and everything so nicely. And let's continue with the session. And we have a announcement for you all, which I'll be telling to you around the end of the session. So till then, let's learn and enrich our skills. Over to you, sir.
Thanks a lot. We'll again jump back to the slides. Today what we'll do is we'll show you how to access an Azure storage or how to you can access Azure endpoint. So I'll show a live demo which I've just prepared. That could be helpful in some way to understand how things work in the real front. So I guess you can see the slides now. Great. So we were covering two of the topics since we did cover only just the first part on both the days. So we covered upon the machine learning part. We haven't touched about all the services that Cognizant provides, or the computer vision provides. So we'll start with this one, and then slowly we'll move into the part where we have more in depth on cognitive services and what are the things that you can use. You don't have to reinvent the wheel again. So these are the things that we already have. We do already have everything with Azure. You don't have to start from the scratch. You can use the existing stuff, whatever it is, whatever Azure gives you. So from the start, we'll just go with some images, and then we'll just go dive into the text part, which is also called as NLP, where you can analyze the text. For the past 2 days, we have handled tables and columns, right? We have some set of columns, some set of a different x and y. We have x, which is the factors, and we have the y, which is the output that we need. So the classification works in a different way when it comes to images, text, and other form recognition and other things that you might see. Mostly, it is done in the first three that we see: clustering, regression, and classification. Most of the images would, or most of the models which deals with images would come under classification, since that is only the factor we use it. We want to see if this image is related to this one or this image is related to something else. So that is what we would see for this computer vision and stuff. But again, these are something which Azure provides out of box. We don't have to uh, train something, or you don't have to do anything much. Okay, first we'll see what is computer vision and why it is used, and what are the places that we are actually using it. Right, we already have started using all these things. We are in the, I would say, above 60 percentage mark of using machine learning model to the fullest. But again, I would say that we are there are few models which have come out. We have generative models which can generate a real person like a real person photograph. So we do have models which can simulate or which can take maybe someone's good dancing, and with just a static image that can generate the movements. So I did have a demo on this one, so I'll not show it this one. I'll put the link down or in LinkedIn so that you can see. It is a pretty cool thing that they have done. So that is all started with computer vision. So how the image is handled and what all you can do with the images. So let's break down what exactly is an image. So every image that you see, everything that you see on the screen or in any screen per se, everything is a pixel. Pixel of values from high to low or low to high. We would have 0 to 255. For every pixel, there is a value that can take. For every pixel, this is the value range that it can go. The brightness, you can call it as, or the electricity that passes through that particular pixel. Every anything that you call it as, you have some range that the value can be. It can be your zero. It can be 255. So we do have this for black and if you have only black and white images, it is fine. You just have two colors which you can show. When it comes to the colored images, so RGB kind of stuff, where you have to have different layers of these so that you get the entire all the shades which combine to give all the colors that you see out there. In the street you can see different colors. You can have gray, you can have white. We do have few blacks in the front of the car and the rear of the bus. So few of the places where you see, I think it is an ambulance, but again, so few of the places that you see have different pixels level. So we do have all these three scales where the complete thing forms a single image, right? All the digital images that you see is you can consider that as a huge matrix or arrays of matrix or arrays of arrays where you store all these pixel value. So you can definitely get an image, see for this particular pixel I just need what are the RGB values. You can definitely play around with OpenCV and try out getting all the values of each and every pixel. You can even print a pixel if you want to. Just print one pixel out of that image uh, and see. You can definitely. It won't be good. It won't be looking nice. It would be really small. But if you want to, you can definitely do that. Or you can create a pixel with this particular uh, range of values in RGB scale. I want this particular range in other scales for this pixel. You can definitely try out few random values for all these, which can generate random stuff, random images. So you never know what would be the output. So this image you can definitely take as an example. So this is obviously they use it to build the model. So the randomization is taken over by the AI. You can definitely do random and come up with an image. So we don't need that. So if you randomize stuff, it can you wouldn't get this complete bus as a bus. You might have random pixels over here, but you won't have a complete package. The pixels nearby should have have the continuity to form this entire bus. So everything that you see as a image, the first thing that you should understand is everything that you see as an image is totally pixels. Pixel with some value. Some value 0 to 255 is the value range. So once you have understood the representation of the intensity of the pixels and what values it can take, and all these red, green, blue pixel values that it can appear, we have three layers of it. Not sure if you can see it, but again, uh, these are the pixel values that you can see for every particular piece of information. There is something behind. So I even have seen this. Not sure on the contest name. It was Wonder Woman. I'm not sure on the exact contest name where they gave a HTML file. It is like capture the flag if you have played that random crazy stuff. The security, they have some events. So I just converted a HTML file to an image, or I'm not sure, image to HTML or HTML to an image. The image turned out to be a HTML page. I just renamed the file, and then it gave me a HTML page. So that was an image prior to what I saw. It was an image of this sort. This sort, I've opened it in the, what you have in the default and Ubuntu, or if you are using Windows, if you have anything, just view it as an image. It was a complete image of this sort. In your view, this would be the image. But once you change it, to change the extension of the file to HTML, it gave me a HTML page, which you can obviously view on the browser. So that was something that, not sure how they did it, but you can definitely explore those in-depth areas of how these images are made. So you also know that every image is tagged with some sort of data. So not just these values. So only these values doesn't construct the entire JPEG file that you guys see. You also have metadata. Metadata is the created date. If you can go to, just take your mobile, take a just take a random pic, and go to the details, and you can see what is the lens, what is the focal length, and what is the model. I think you have few details that you shouldn't be giving out, but it is already there. So, but by default, you have all these data, in which cam it was taken, what was the lens version, and all the different characteristics of that lens, and what was the location if you have turned on your location on your mobile. So all these data you have inside an image. So we don't have any external storage to store it for the image. We don't reference it from anywhere. You just copy an image, put it on your laptop from your phone. You go to the same details, you would see the same thing. So once, only if you take a screenshot of it and then move it to a different device, you wouldn't be seeing it. But in all the other cases, or at least most of the cases, you would definitely see only the exact data or exact metadata that you have shared. That is your, I think a date, create a date, modified date, and there are a few things which you can refer. Just go to your, take your mobile if you have it in handy, take any random picture that you have to of yourself, or you have to go random portrait. Just go to the details and see what are the data that you are giving out with an image. So image is not just these boxes. So these boxes have the pixel values. That doesn't mean that only the images just have these, let's say 100 cross 100. It is not 100 cross 100, it could be less. But just for the sake of telling, if it is an image, you don't have just only the pixel value. So 100 cross 100 you would just have, or you can take 10 cross 10, which you have 100 values. So it is not just a single array which has 100 values. So we also have these metadata. So I want to make sure that you understand that particular phase. You can explore more on that, how the thing is stored. We do have a few things that you can do with that. If some I think there was some image which, if you click it multiple times, it kind of hangs up your phone. I'm not sure if you have seen it, but if you know what it is, you can put it in the chats. We could see how that works. Even I'm not sure. I have seen it somewhere, not sure on which platform, but there are few things that you can, tamper with just an image. So all I'm telling about is a single image. You can do all these stuff. You can embed code in it. You can do whatever you want with a single image. So this is how intense, or this is how deep down you have to go for analyzing stuff. Okay, coming to the interesting part. So hope you know, we will just give the model this image of, of a taxi. Every model that is trained with some sort of data knows, or every human at least knows, this is a taxi which is painted in yellow, or it could be a golden yellow or something. But you know that this is taxi by your, by someone learning from someone, right? Let's say if your friend is telling about, this is the taxi you're just seeing for the first time. Let's say this is the first ever time that you are looking at taxi, but you don't know, you don't recognize that, right? Someone has to tell you that, hey, this is called taxi, you can, pay them to go anywhere. So that is a description of the taxi that someone has to tell you, so you remember that uh, in your neurons, obvious, and then you recall it whenever it is needed. So it is the same exact stuff that the machine learning algorithm does. So it remembers stuff you call the same as neurons. So we do have a similar structure to it. So that is why it is called neural networks in the first place. But we wouldn't get deep down into that space. But again, you just need to remember that there is something called as neural network, which kind of resembles stuff. So whatever have you recognize, so that is why people build, human-like robots or human-like behavior. All these are done by whatever we have in ourselves. We have a brain which has neurons which can store data. So all we do is store data inside our brain. So whenever you see something similar or you recall it from your memory, so that is all you do. Similar stuff for recognizing object. If you have a traffic cam, it is obviously a traffic cam which kind of spots different stuff. So if you see some activity which is suspicious, you can trigger something, and they can the police can look up to it, or the chiefs can look up to it. So these are the technologies that we already have, right? So we already have all these in place. Most of the you know uh, grown up countries or developed countries use it or have it as part of their, you can see it in China, Korea, and Japan. So those have advanced technologies which they have deployed. It is not just they have it in theory, they have it in their offices, they have it in public places. So another part is where you shade that portion. So as I said before, you know that this is the pixel value, or this is the pixel which constructs this particular ambulance, if you call it, or a truck, if you can just recall it in that space, or you'll take this car. So what are the pixels surrounding this car make this car? So that is what the machine learning model has to tell us. So if it can recognize these people, these two people as cyclists, then what are the pixels that make this cyclist? So for us, we know that there is a cycle, there is a person sitting on it. So we know that by that relation, they are called cyclist, or they have some movement, or you recognize that particular piece of data. For a neural network, they don't have all these senses. They know that what kind of pixels, or if this pixel is in this shape, or this pixel is in this particular order, right? This particular order, then that it kind of tells that this is a car. So that is all it does, or that is all it knows. If there is a road, it kind of recognizes this as a road. So it already knows that if the road has stripes on it, white stripes on it, it is a road. So it remembers that. When you say that give me this, it kind of recalls it from that particular memory. So this is how this uh, part of portioning works, or if you can call it as the exact word, segmentation. So that is something, it is a bit advanced. So these two, it is, you can understand it better and easier than this one, but try to catch up with this one, uh, so it kind of eases out. But this is also a model which you can try out. I'm not sure on the name of it, but for object detection, you can definitely use YOLO. So YOLO is you look only once. So that is a model which is pretty famous among object detection. It can give you whatever images that you take, just feed in the model, just take a snap, and then you'll get these bounding boxes and the tag of it. So it is called tags, or you can use other word. But this box that you see, all these four coordinates make a, it can make a square, it can make a rectangle, but all these four coordinates is the key. So it knows that within this there is something. So it kind of strings down stuff. It doesn't know that the first phase that this is a truck. It kind of scans through the entire stuff. It kind of narrows down. If that it kind of has these pixel values, so it kind of recalls it from the previous memory that it has. So it kind of tries out, if this is the case, and this has to be a bus, or there has to be a bus in this bounding box. But in this case, it just exactly gives you the shape, or it kind of exactly finds the pixel which makes up this truck. So this is very powerful, and this is something that we have came up with, uh, really, with all the research from the team. So this is something that the researchers are working on daily basis to make it perfect, and we do have already perfect models available for ready to be deployed. Just deploy, you don't have to even train it, so it is already pre-trained, the weights are already assigned. Just use it. You can just copy, or you can just clone the repo. You can have the model, and then you can start using it. So we'll just skip through these two parts real quick. So this is really complex. So the third part we saw is somewhat complex, or it is more complex for someone who's learning machine learning or computer vision for the first time. But this is really something that uh, people have worked on. So how this has two phases. So one is the part where you recognize the image. The second part of it is how you construct the sentence. So a person with a dog on a street. So what are the words that it has used? There is a person, there is a dog, and there is a street, and we do have cars, we do have buildings, we have traffic light. So but we do have a dustbin over there. So we have trash can. We do have few stuff that you can see. That is almost everything that you can name. If you see something else, you can definitely put it in the chat. uh, so this is something that this is more advanced. So we do also have other advanced stuff coming in, so we which I didn't have it in this slide. So as I said, the neural networks are really powerful, or the generative networks are really powerful, which can generate a whole new person. uh, they wouldn't be existing in the world, but it can give you a face of someone who has never existed in this world. So that is how far we have gone with this computer vision, or if you can call it as machine learning, or whatever term that you coin. That is the extent that we have went to generate an actual person who is not alive. So that is the reach of machine learning that we have come up with. So these things have been into uh, been in theories and papers. A lot of papers have come of earlier times. So it is not just this time the machine learning thing has boomed, the neural network has boomed. We do have papers from 1990s which kind of tells all these talks about all these networks, all these things that you can do. But we didn't have the compute power for it. So in 1990s, even we didn't have 1 GB RAM system. So we just started off with personal laptops and personal desktops, I would call it. We didn't have even laptops in 1990s. So that is one thing that we didn't look up to all these stuff when we started off with machine learning, or when we started off using systems for writing code, since it requires a huge computing power which we didn't really had. So as you know, you now have terabytes of data just in one stick, right? You can have, I think there are a few companies which make it just 1 terabyte of data in one simple stick which you can hold in your hand. So it is not even hard disk size. It doesn't fit in your palm. You just need to have single stick, which could be 5 to 6 centimeters long, and three centimeters in width. So that is how far we have come with in the chip industry, in the electronics industry. So that is the way. That is the only way that we are able to achieve all these things. What I am showing you is achievable only with all these huge computing power that we have today. So this obviously you might have seen. You might have seen the face detection, and hope you have seen also the if someone is wearing a mask or not. Most universities, most organizations across world use it, which is not perfect. Again, you can just have so you can, even if you can see on your phone, some phones have these older models where if you can show a person's image. So let's say if you want to open your friend's mobile, you can definitely show just his face to that particular mobile to unlock it. So we were able to do that. But there are few models which came after that, which didn't allow us to do that particular phase. So it is always developing phase. We don't have like a exact model which can tell that this is the right way. We don't have a model of such kind, but we are trying to improve always. So whatever face detection model that we have now, it can go up to some extent. It can't be 100%. So as you know, from thermodynamics, if you know, efficiency can't be 100%. So that is how things work in real life as well. So it applies to everywhere. It is not just thermodynamics. It applies to, I think it is the third law. So it applies to everywhere. You can't achieve a model's accuracy with 100%. If you do, I have done couple of times. If you do that, that tells that the model is not perfect, or the model has some kind of a defect to it. So if that model is 100%, then it tells that it is not trained in the proper way, or it is biased a lot. So that those are the only two possible explanations, or there could be many, but these are the earlier possibilities, that if your model is 100 percentage, then there is a serious fix that you have to do in the way that you're training the model. So this has been there for a long time. You know that OCR has been here. We know that how text are recognized. You are using a PDF scanner or whatever you want to use in your mobile to scan text. So text is pretty simple. So text is easier to do, since you know that this is the pixel that is gonna make this particular piece. Let's say T hits T is always T wherever you put it, in whichever form you put it. T is always T. There are few letters which could be confusing for a machine learning model, such as what do you call it? So maybe O and D, so which is pretty close. We know that there is a difference. O and D could be pretty close. Again, I and L, if I is caps and L is the lowercase, then we sometimes I do have this problem when there's the font thing, which kind of which has very little, very tiny gap between identifying L and I. So if the L is smaller and if the I is caps, then that there also you have this problem. So, or even this, when you have this, when you have a randomized password, when you try to enter it somewhere, you have to manually do it. That is where this problem I have faced of which one to type, right? So if you type it three times or more than that, it kind of strikes. So what you do is copy that, or type something in the same font somewhere else, and see if that suits this one. So that is something that we have seen for a long time. OCR has been here for a long time, and we have some perfect models which can do it. But for O and D, as I said, it is a bit harder. If it is if the O is in uppercase and D is also in uppercase, that could be a little bit difficult for the model. But again, you can fine tune it a lot so that it kind of tells. So it is all about how you train it and what kind of data you give it, that makes a model great or worst. So computer vision. So coming to the interesting part. So this I'll show you a demo right away. You'll see once the slides are done. So this is how simple it is to start a cognitive service. Start using all the things that I have said, all the six slides that you guys have seen. So what you all need is just the model space, what kind of model that you need. Let's say I want a classification model between a dog and a cat, or I want some classification model, or I want to have the image recognition model or OCR model, whatever model that you need. From the computer vision, we do have all the we have covered most of the cases, I guess. With cognitive services, I think we have 7 or 8 use cases. They have identified it, one of the frequent use cases, right? So frequent use cases that people use a lot, they are trying to build a model from scratch. So what Azure has done, or the team from Microsoft has done, is they have collected all the data, and then they have trained the model rigorously so that it can give you the most accurate result all the time, or at least to some extent. So that is how uh, we have trained stuff, or they have trained stuff in the Azure space. So what you all need is two things. So this is a really important thing. Obviously this would be in your exams, by the way. So what are the things that you need to consume a cognitive service API? So that is how the question would be. So I didn't kind of say the exact question. You might get some similar questions. So have you used this stuff for sure? So, but pretty much you might get this questions. Obvious, know that few of the questions are straightforward, but only few are trickier. So obviously you have some kind of easier questions, or 10 to 15 questions would be really easy of this sort. But everybody would know answer that, right? So you have to cross the 50 percentage mark. So that is the hardest phase. So everyone would feel that 30 questions are really easy. 30 questions would be straightforward, or there could be some sort of trickier spot. But for other spaces, it is pretty easy, or uh, pretty simple to solve. So what you need is a REST endpoint, which I would show you in the portal itself, which you guys can try. I wouldn't share the key. I'll just revoke it once this is done. I'll just show you the demo so that you can understand how that works. I do have this on the GitHub, so if you can look up to it, I'll share the link down below. Just a sec. So, and you also need a key for using it. So key is a random string. You can have any string. You can just put it in your environment, or if you put it in a file, you can load it from there. Whatever you do, you can, when you host it, make sure it is in the environment variable. So don't store anywhere else your key. Even file, never do that. Always have, always store this key, or the URL. If the URL you want to have it from the environment variable, it is also fine. I'm saying it in from the Python's perspective. You have this environ variable where you can get all these as a dictionary. Just give that value out, and then you can get that particular key, or whatever value that you have stored for that particular key in the dictionary. Okay, so this is something similar. So this is a bit advanced again. So you know that this is a person, right? So we know that this is a person who is walking, right? So this is a different model. It kind of gives you that he's a person. I would say to extend that, if the model has given that if it's a male or a female, that would be even better. But it is also giving you the age. So age is 34. So he's wearing a jeans, and it has also seen a footwear. So we do also have footwears over here. We do have also footwears over here. So why it has not picked this up? We do have footwears over here. We also know that there's a footwear over here. And what else, which is really tiny, we do also have a person over here. For us, we know that this is a person because we scale things up, right? We do also have, we can count these buildings, so how many are there by just seeing at it. But a model doesn't know why. The pixels are very less. So if you consider the pixel of this person who is at this who is at the last, right, and consider the number of pixels that this person takes in this whole image. So it can't scale up this particular part alone. It doesn't do that, or you have to build something which kind of does that, so that it can pick up this particular person as a person. We know that there is something. Okay, even I have to increase the brightness to see what exactly very tiny stuff that we could see. Okay, we do have trees and stuff. We have post. I think this is the tiniest thing that I could find. It also have something here. I am seeing it from the presenter view, so that it is even smaller. But you guys can see it in the full view. So it is. You can just find something. If you can find something, just put it in the chat. So this is something that these models are not trained to do, right? We do also have footwear, so the pixels is something that it needs, or it is the form of data that the machine learning needs to kind of detect stuff, right? So the pixel of this person is not the same as the pixel of this person in the image. So consider this as the data space, and the number of pixel of this person is not equal to this, so that is why this has not picked up. So that you could fine tune it in such a way that you could kind of, so there is a process of doing it where I'm not sure on the name, but you can duplicate the pixels nearby. So not sure if this is something that you guys can do it in Photoshop. Not sure how that works. You can definitely explore how these tools in Photoshop work. Do they have, what kind of code that they have written? If people are working from there, obviously they know how it works. But for normal people who are outside the org, you may not know it. But there is a way where you can pixel this out, right? So we know that this part is span, right? So we could scale this up to this entire space. We can do that, yes or not? So anybody has any idea on how we could accomplish this, or have this glass strip? We know the shape of it, we can scale down. You have used tools in Word or any other uh, photo editor where you can scale things up, right? You can scale this entire thing to maybe the max, but it is only the view that scales up, it is not the pixels. Again, if you kind of cut this out and then save it as an image, or take a screenshot of it, or save it as an image, you're cutting down this part of the, or this pixel part of this image, and you're storing it somewhere. But for your view, it could be larger or it could be bigger, but it won't be perfect. The pixel, you can see that that is too pixelated. When people call the word your photo is pixelated, that means that you could see the pixel. So just go in front of your screen. So if it is a 720, you can definitely see the pixels, but if it is a 1080p screen, it could be a little bit harder for you to see. But make sure you have the entire stuff in white. You have just make sure, I'm not sure if you have the image, but I did have an image where it just has one green pixel or one red pixel, the entire image. So you put it on full screen, you can see that one pixel of your complete screen, complete 1920 by 1080, the entire screen, that is the maximum pixel that your screen can take. If it is 1080p monitor or 1080p screen in your laptop, so that is the maximum pixel that your monitor can show you, right? So if we just move a lot closer and look at your screen, I'm doing it right now. So really, just uh, really go very close as you can. Just don't bump into the screen, don't damage it. Just go really close and see. You could see the individual pixels of your screen. So anyone could see that. Okay, fine, we'll let you see it afterwards. We have a few stuff to cover. So you could definitely see that black pixels, or I think it is easier to see. Or just make an image in OpenCV, we have only one pixel in the entire image as some random color, whatever color you like, and then you can see that individual pixel is lighting up in a different color in your monitor. So that is something that you guys can try. So I don't want to go into too much of this. So this is something that we have seen already. Object detection. So classification is, that it is an apple, orange, and banana. But how, if you put it in the same space, we have the entire space, and then you just need to. So the model is telling that apple is still here, but we know that apple is only till here. but so the model is not exactly perfect. Even you can use the cognitive service provided by Azure, I don't think it would be really accurate. So this one is accurate, right? This banana is also here, but it kind of went a little longer. It might be due to the fact that they have trained it in such a way that it could be the bigger size, so that it is obviously fits in the object fits inside the bounding box or bounding area. But you can definitely try out with it. Just it is all comes to how you train the model to kind of see that particular thing. So this is interesting. So this is very very interesting. We do have different features which you can explore. So name, I don't think it can give you the name. It is not, it is like impossible. Or you can train a model, but it won't give you the exact name of a person. Uh, but obviously age and happiness is something that happiness, all the emotions that you see, you can definitely train. So it is 75 percentage, I'm not sure why it is, and this is 92. So it is all with the myth of, or it is all with the data that it has just the image. The person could be really happy or sad, but based on the width of their smile, you can't say that that person is happy. You can say that to some extent when you crack a joke, they might laugh, or if you do something funny, they could laugh, or if you give them something, you can gift them, they could laugh and smile. But this is completely in relation, or in a relationship with the emotion part that we could see as a human being. But for a machine learning model, you just feed in the data with the image. So there is nothing attached to the image that tells the model that this is the incident that invoked this kind of behavior. So we know that if a joke is said, how much they can laugh, or if something really good thing happened, like let's say they have placed in Microsoft itself, they could have a different kind of, or a different level of happiness. But the machine learning model doesn't know that. So if some people maybe they could be really sad in some space, but they would be happy inside, so just to pretend that they are sad. So that could be of different sort for different examples. But this model just gives you, or kind of gives you the face part. So have you, so all these things that you see are already pre-trained and you can just use it. So I think it is all done. So we'll just go to the demo. So it is also the handwriting recognition now. So it is not just the text that are printed or with the printers. It can also recognize text which is written by hand. So it is bit difficult for a model to tell that. Again, as I said, there are few letters which overlap with each other. Even in this case, it is really hard for a model to tell if it is uh, none, or if it is a. So a is also something, you have this particular piece. I'm not sure if I am hiding it, but in the fact you see a which kind of extends to this space, we also have something extending from this space. So everything that the model knows is this, there is some pixel in this image that it has to find the pattern. So this pattern is pretty simple. S would be an S anyway. This is the pattern it follows. So we know that this is, if this pattern exists in an image anywhere inside this image, we know that that is an S. But this part is pretty tricky to find out. Even if let's say if this sentence is not there, right? So let's remove all these and remove all these. So it is a plain image, and even you don't have this n, right? If you have this n, some people might find it as none, so, or non, if call it as. But if you have just these two letters, and if you call someone, even humans can't find out exactly, only the person who wrote it, or if the if the person has an habit of writing of this sort, or if they have seen their friends writing of this sort, they could recognize it as o or n. So that is something, it is really tricky for a model to give. This could also be a o or a. That totally depends on uh, the person. But again, it is also the only the data part that you have, you're also constrained now. So you know that only with this image that this is the space with all the knowledge that you have from your childhood. You have been writing, practicing all this stuff, but even for you it is difficult to find out if it is a, when you remove this and it is difficult to find if it is a O or a. But so let's say if it is difficult for you, then how good a model can be. So just think of that scale. Even if it is difficult, there are certain things which is difficult for us. So what is up next? Form. I don't think that if we can, I can talk about for a minute and then we'll start the demo. So form recognition, I don't think it is pretty useful in any form. So if you can print a form, right? So why do you need to scan it anyway? So it is gonna be computerized, and it is gonna be, a machine is gonna print it. So why do you need a form recognition in the first place? I have this question, and I'm not sure why people still do it. You so this is coming from a, so in this case, right, so there are pretty old systems where they have this lips which comes out of non-screen stuff or less screen stuff. You have this pixel displays, not sure the exact number, even I have worked on that one. So we have this green pixel box that you have. If someone can name it out, that could be really helpful for me. So that is called an LED. I'm not sure on the exact specs, 16 inch or not an inch. It comes in some kind of pixel numbers. But if you type it in that space, that is when this is important. So if it is coming from a from a computer, then you can definitely just just save it as a PDF and you can print it out on a printer. Why do you want to scan this, or you have all these data as a CSV file, obviously, or if you have it in the Excel file, you can definitely use that, put it into a database, whatever you want to do, you can do it. So this, I think it is only for the old systems which are not modernized, which are not digitalized to an extent where you can save it in the database as well as print it out in the form of these small chits, if we can call it as. So that is when it is important. Otherwise I don't think this even makes sense for being a model to scan a form. So so even that this is, you don't even need a machine learning model to do this, since that this is the place where your you know part of this, you can do it in OpenCV. So that all the ordering that you have done is lying on this below these two lines, right? So that this is the space that you have to scan for taking out all the orders that you have made or something that you have bought. So it doesn't need a machine learning model to do it, but it can do it pretty accurately, since it can go to 5, 6, 7, or 8, or 20, or 30. 30 is too much, but if it is going beyond 5, OpenCV can't hold up to it, since the format could change. If something is too larger, it could go till here, and the dollars could come here. So it could be really confusing for the model to, or the OpenCV static thing to do. So it is the same for the NLP as well. So I'll show you the demo now so that we could see something. Oops. Okay, hope you can see my portal. So this is the portal that you do click on. So you don't have community services right over here. If you can, just click on it. But if you don't have, click on create a resource. It would take you to a page where you can type something out. I would ask you for suggestions. You can click on that or just hit on enter. I think enter is taking too long. So even it is not just Azure, you can also search for other companies which provide these sort of services in the marketplace. So it is not just you know, only you have to use Azure. So yeah, as you can see, these are not from Microsoft. So you can see these are from Microsoft. So the language service or the machine learning, computer vision phase that we have seen. So all these are from Microsoft. So these are from various companies that you can use. So they cost, I think, an additional. You can see they have a base and a premium and health check, all these stuff. So they also have a different way of approaching it. So this is also something that you guys can build. So Azure managed services for professionals. So this is something that you guys can explore. But obviously, what we need is a cognitive service stuff from Azure. Let me type it again. I think I'm searching it in the long page. So as you can see, if you just type cognitive services or COG, the first thing that would come up with this one. So there are two things that you can do with this one. You can select different services just as a single stuff. So I just want speech service. You can just click on speech. If you want to language translate stuff, you can do. You also have a Q&A maker. If you have asked for any help with the chatbot on the screen, this is how they do it. So computer vision, whatever we have seen so far, analyzing images and videos, but we didn't see any videos part. But image is something that is enough for this particular path. If you want to go bit advanced, you can also have fire detection and other sorts of disasters that you can look up to. If let's say if you have a surveillance camera and the fire is caught up in a apartment, which, let's say if it is a New Year's Eve, everybody goes out, there is a fire in the apartment, nobody is there. Let's consider that as an example. Nobody is there, and if they come up after 1 or 2 a.m. in the morning next day, then the entire apartment could have been burned down, or at least it could have some damage. So that is something that you guys can try for the video analyzing part. And this is something that you guys can use. So you can select one particular stuff and you can try. Let's say if you want to use just image, so I just for my use case only the computer vision is fine. Well, I just want to analyze only the images and videos. I don't want any NLP. I don't want to have any sort of other services given by Azure. You can select this one, but I have selected this one, which where you can use all these services which are listed, which is very easy to kind of see. So as I said, what you need is an endpoint. So this is an endpoint, AI 900 cognitive services dot cognitive services dot azure dot com, and what you have is a key. So this is the endpoint that I've showed. You can always choose East US, so you have a pretty uh, good stuff going around there. You get a lot of free tire stuff if you choose other regions, yeah, especially in India. I don't think you have a lot of the free tire stuff, which hasn't been deployed since most people are not using it as in US. That is why they haven't brought any of that thing. So you can always recommend it that you choose East US. So with this one, okay, I think I have to share the stuff again. Okay, I guess you guys can see my VS Code. Okay, nice. So what we have here is this is something that I did. Few of the code is from the docs. I wouldn't like that I have typed all these, but few of the things that I did was to kind of have a flow which you can pick. So these are the list that I have picked. So there are a number of things that you can do. This is something that I have picked: find faces, get images, image tags. So this is something that I did to just see. You can execute this particular function. You can just get user choice of doing things. Okay, so what did ask this code to do? So this is something that we will use. So just go to this URL. I guess you would find. Not sure if I can open it here. It kind of redirects. So I'll just put it in the chat. You could see what exactly is the image over there. I should have downloaded it so that I can just show you. I think I can do it now. So until then, just go through the code. I'll just come back to this. Okay. So this is the image that. So this is the image that we have. You can put it on this side. So this is the image that we have. So hope you would recognize three of the faces. Even I'm not sure who is this guy, but uh, so let's see. So this is the first thing that we would select if you just go to this URL I have shared. So you would get this image. So this is a sample image from the Azure documentation. Hope you get recognize three people. So we could just type one. So to find the faces, that kind of calls this particular method. All it does is gets the URL that it needs, go to the client. So I'll just show you the code, what is exactly the code does. So this is where you load the environment.
Uh,
I do have a
Sir,
.env file. Yeah.
sorry to interrupt you, sir, but it would be great if you could please zoom in a bit.
Oh, okay. Sorry. Yeah, forgot that. Is it better now? I guess you can see a little bit
Yes, sir.
large.
It's good.
Okay. Okay, so this is where these are some of the files, imports that I have skipped, that you don't have to worry about. So this is where you load the environment. So you don't have to store it hardcode stuff anywhere. Just make sure you load it from a file, or for local deployment, a file would be fine. You don't have to you can do it in a virtual environment. That is the best thing to do. What I have done. But if you have it in a file, it is also okay to have it in the local space. You can have that, and then get the key, and this is the endpoint that you'll get. So these are the two things that you get, or that you need to create this client. So this is a client, it says provided state of the art algorithms to process images and written information. So this is the documentation from Microsoft. You can just go through this. If you want to just pick up any random image that you find over Google. I'll share, I do have this on GitHub, uh, this entire code base. You can look up to it. I'll drop it in the chat again. So if you want to look at the code, we do have it on GitHub, so you can look at it anytime. So this is what you create as a client. So once the client is done, you establish the connection with that particular endpoint. So we do have that particular stuff going around. So what you need is a URL or an image. So as an image, you have to convert into an image. So that is where when you need the pillow and other libraries if you want to use it, NumPy and stuff. But if you just give the endpoint, if you have it in a remote storage as we have it or now over here, uh, cognitive services, the example part, it is in GitHub. You can definitely use that space. But if you have an image locally, that is also there is also a possibility. I'll upload another repo or I'll update this code where you can have a switch between if you want to give a URL or if you want to give an image. So I'm not sure on which space I left. Can close stuff. Okay. So we it is asking for which function to choose, and we'll say find phases where it is. We do have the find phases. What it tells. Just go through it really quick. So just take a URL and just insert it and what you want to find. So so it tells us what model you want to use, the URL you want to use, the language version, and all the stuff. We want the celebrity model and what is the URL of the image. So those are the two parameters that we are giving it. So it kind of loops through whatever the celebrities that we have. If there are nobody in that level or the people in the celebrities level, it kind of prints this one, or else it kind of loops through the entire stuff. So I'll just quickly type one. I think it might take some time. So as you see from right side, okay. So model has given it from right, then left, then Bill Gates. So Steve Ballmer, as you can see, from the right side, it kind of went to the left, and then it went to the center person. So it kind of jumps, but again, it kind of gives you the at least the celebrities that you can see or but this guy could be important, so he might be at the top of some point, but I am not sure who it is. But this is something that you guys can try. So all these services are given by Azure for free to some extent, that you can use these models in your projects that you want to build for a hackathon or anything else that you guys are building. This is something that really effective. You don't have to waste any time. It is not just celebrities. You have a lot of things that you can do. I think you can also try this one. Get images, get image tags. So I just need to download this again, but we'll just see what it kind of gives us. So get image tags. So what we saw earlier is what are the things that it can give us, right? So we don't have the image, so that is fine. So it tells us it is an outdoor. We do have a building. We do have a sky stadium. So I'll just download this image, and you guys, if you have any questions, just put it in the chat. With that, we'll just close it out. Okay. So this is the image that this is the exact landmark.jpg. So what it says is it is outdoor. Obvious, it is 99 percentage. We know that there's a sky above, so it is obviously an outer image. And it says it is a building. I don't see an exact building, but you can consider this as a half built or half ruined building. It says it's sky. We don't see a blue sky, not pretty blue, but you can take it as a blue. And stadium, not sure how it tells that it is a stadium. We see some space. It is like an entrance where people come and perform here, and people could watch from here. So it is of some sort of that. So ancient Rome, it could be. Even I'm not sure from which it is. So historic site, ancient history, ecological site, all these stuff. It also has a confidence level. So city, large, travel, large. I don't think that is a tag at all. Large, if it is a large image or what exactly it is, I'm not sure. So this is how a real model looks like. So they do have fine tuning work to do. It's not just, even these guys haven't fine tuned the entire stuff. But the first three, I would give kudos. The first three, it is absolutely right. We do have a sky, we do have some sort of building, fine. Outdoor is fine. So outdoor is something that we need as something that if you see a photograph, if it is indoor or outdoor, then you go for classification. That is how they have trained. So that is how it is giving out the details. Travel, that could be somebody who is traveling could have taken the snap. And the city, I don't think it comes under city. Maybe a travel city or a tourism spot, that could be a relevant tag. I think we do have that historic site, so it is something relevant, which has a high confidence. So these are like low confidence. The model doesn't know that this is something I'm really confident about, but I'll just put through it. So I think they have used 50 plus. I think we can also tweak it a little, so just to show things or tags with some sort of accuracy. So to some extent, let's say I want only 90 percentage and above, what are the uh, you know tags that you can give me for this particular image with 90 percentage accuracy? So that is something that you guys can check on. I think there could be a possibility where you pass it as a pass the URL. I'm not sure. Model version, custom header. So I think the raw is something where you can just put an image, raw image. It can give you. So possible includes language, what language you want this text to be. So all these things you can read through the docs for more info. So this is something that you guys can try. Definitely try this out and see how things work. It could be really easy if you can just code this out or just fork it from the repo that I have shared. You have the link in the chat, in the live chat, I guess. So they have pasted it in the live chat, so you can definitely look up to the GitHub repo. Just fork it, just try something out, work on it. So this is really easy to do. Okay, slash, and so it's a black slash. My bad. So you can also edit this one, no problem. You can just edit this stuff. It is not a big deal. So choose from below. You can choose anything. Just give it a number, and it kind of calls that particular model. This is something in Python, but again, you can have just an idea. You don't have to. If you're familiar with it, you can play around. You can alter the code in any way that you want. But again, I have written it right here, and the wrong part is there. Fine. So, any questions? Any questions that you might have? I did see a few questions before this. I think I have missed few. Someone has answered it. Great. So accuracy, that is the exact formula that if you want to use it. So how it is measuring it, on what basis? In the first day, we see the matrix. We did see the exact matrix. I think I'm sharing a screen. I guess. Okay, let me check. So accuracy is the exact formula. You can just substitute the values that I have shown in the first slide. Uh, the true positives, true negatives. You can just have all these values substituted in that formula, and then get the accuracy right. And example, okay. So as I said, it is not just too accurate to exactly tell that this is a really good model or a fine-tuned model, right? As you see just now, I have triggered a Azure endpoint, a cognitive service one. Everybody gets the same model. Even if you put the same image, it is gonna give you city with an accuracy of 56%. So that is how it is. I wouldn't say that as a bad one, since it has a very low accuracy than others. So when you compare the accuracy, it is way below, right? When you have 98% accurate, it is saying something, and you have something way below 56. So it is a huge gap. I wouldn't call the model is not getting trained properly, but the way that you could see that is something different. So you have a model which is mature enough to tell that, with 50%, 60, 56% accuracy. It totally depends on how the way that you have trained. So let's say you have trained with a lot of outdoor images, then it could tell that with good accuracy that it is an outdoor image. But for other stuff, for other images, let's say you have taken a snap of your keyboard, laptop keyboard with the color lights and stuff, that could, then the model may not give you any tag at all. So if the model hasn't seen any image of that sort, it could give you a model, it could give you something, it could definitely give you some sort of a tag, but it won't be perfect. So that is something you should be careful on, building. When you're using it, it is fine, you use it in any way that you want, but when you're trying it out on your own, make sure that you do something uh, meaningful. Make sure you have a mix of images, or just sit with your use case. So if it is your use case is you're using a surveillance camera to monitor outdoor stuff, make sure you have more images from the outdoor stuff, or similar things that you would tackle in the real life, right? So if someone is training a model for Tesla car, so Tesla S model S, then they would obviously choose images which are outdoors, right? It is obvious that car would obvious be on the roads. It might be in the forest area, it could be on the city part, uh, streets and stuff, but more people would try to ride that in the city, or they would, if it is a forest, it is also possible that they could ride it in a forest. So let's say a different example, nobody is gonna drive a Tesla S in Arctic. It could be possible. That is a possibility, but nobody, no, frequently does it, right? So that there are few possibilities that it might happen, or it has already happened. So if they are training with Arctic images, there is no use of training a model with that. But it could improve it some extent, but the real use case is something different. We need a model which can give you the traffic light. This is a traffic light that it is, or if it is a person who is passing by the car, or if the signal is in red, yellow or green. So all these things that you should definitely take into account while developing a model. So that is something that I want to tell. We do have a quiz tomorrow, swags and stuff. We do also have certification coupon. Make sure you join the Discord channel that we have. Uh, I think it is in the description of the, yeah, video. And we also have a feedback form that you can fill out. Just go to this link or scan with your mobile, whatever you're comfortable with. The page might be a little bit low, the loading time could be a little bit slower side, since most people are filling it out. But again, make sure you join the Discord for tomorrow's quiz. We do have some tough questions. I wouldn't say tough, but it is okay. You can also use the Discord, the link that is shown on the screen, to just type it out, click accept invite. Make sure you have a Discord account to join it. Or you might have used different platforms. So Discord is something really nice they have done. It is not just for gamers, since I have used it for that solely before, but haven't used it in this side. People have started using that more, since it is more similar to Teams, I would say, where you have this chat with different people. You have different Teams. What happens is you have to call Teams inside Teams, so people might get confused on that. But we do have channels inside a team, so that you can spread out things. So that is something that I was always been looking for when this Telegram, WhatsApp launched, where you have dedicated stuff inside a group for discussing things. So if it is a quiz, we do have a quiz channel. If it is something general chat, we do have a general channel. Another advantage of using Discord, you have voice channels where you can just jump in and ask many questions that you want, or you can have general discussion. So if two people want to discuss something, and if some more people want to listen, you can do it instantly with the voice channels that we have in the Discord. So that is something that you can leverage. Whatever we give out, make sure you utilize that to the fullest.
Yep. So I must say that Saras covered each and every part from very scratch in this boot camp. And I think Bhavesh is saying nothing is there. Uh, I think Bhavesh, there is some issue with you. I have personally checked both the links. I have found in the second link, which is being displayed on your screen, the sir has shared the repository, and in that repository, please go and find the snippets.py file, and you'll find the entire code which sir displayed here during the explanation. And guys, I have also shared our Discord channel link in the description, in the live chat, as well as in the description. You are able to see it on your screens as well. So I'd highly recommend you all to please join our Discord channel. And tomorrow, for sure, we are going to have a quiz on AI 900 itself, and where winners are going to get Microsoft merchandise. And also, every Friday we conduct a quiz in which there is a prize. Like for the previous week, we had a prize of, I think, $20,000. Top 20 participants were given $100 Azure passes. Like someone was asking yesterday that what to do if my Azure credits has been expired, or how can I do more advanced stuff which Azure do not allow on the student subscription. So you can get the Azure passes of $100, and you can play with Azure up to the extent you want, and it's going to be free for you, you know. And obviously, when you get awarded for learning, it's very nice, and you are going to learn more. So I'd highly recommend to join us for the quiz as well on AI 900, and let's see if there is a quiz on another thing as well. And as sir has briefly explained you about Discord, that there are individual channels for each and everything. You can go, like in the live chat only, there was a person who was like Pooja asked what is the measure of accuracy, and Kishore explained, and all these things. So live chat is a very small example. You can go on Discord, you can interact with thousands and thousands of person, and each and every single doubt is getting cleared. You are going to get expert mentor support. We are having many experienced person, like let's take the example of Santosh sir only. He is also at our Discord. You can go directly interact with the person, and if he is busy, someone else will answer your query, but your query will be resolved. And as well as we are also having dedicated channel for the resources, where you can start learning Azure from very basics. Just go and uh, go there and say that I want to learn this stuff. Someone will surely reply you with the resources, or if no one, then we guys from our backend are going to discuss with you what you want, and we'll try to provide you. And if you guys want to conduct hackathons or boot camps or sessions in your college or in your locality community, then you can directly put the things in the Discord channel, and we'll get back to you. We'll provide you with the speaker, mentor, each and everything. And at last, I would like to thank our mentor, Santosh sir, who came here, gave his 3 days for such a nice session where he covered each and everything from very scratch. You know, guys, I hope you all must have learned a lot from the person. He's a very experienced person, and the way he explained the things was really nice. So, a huge shout out to Santosh sir, and we hope to see you, sir, in the other boot camps as well with another topics. And I'd like to thank you all for being so patient and learn the things. Thank you very much, guys. Thank you for being such a lovely audience.